It's basically a robot that automates farming in hydroponically. So it's, like conventional farming uses soil. We don't use soil because it's hydroponics, and we automate the process. So the whole goal is somebody can just put in some seeds and then it will grow a full lettuce plant itself, and then you just get it at the end of the day.
Farming's hard. It takes a lot of labor. So there are methods of farming called hydroponic and aeroponic farming. Aeroponic is where the roots are suspended in dirt and water is sprayed at the bottom. Hydroponic, the roots just sit in a channel of nutrients. So we are trying to automate a hydroponic system. It's way more water efficient, gets better yields, and uses way less labor.
My name is Benjamin Kensington, and I'm a computer engineering major going for a cybersecurity concentration. We call it the ASGS farming system. I served as a little bit of a polymath and a flex on this project. So coming from a more networking and cyber background, I didn't have as much experience with embedded systems, but Dylan was really awesome with kind of pointing me in the right direction and helping me figure out what I need to work on. So I started out with smaller requirements like make a display. So the display that we have on the machine right now, all the screens, that was some of the work that I did. We also have some timing requirements. So for example, we need to keep track of a daily light integral. And in order to do that, we need to know when midnight is. Some of the other work I did involved creating some time checking functions to see, are we at midnight? How much time has elapsed since the system is on, since time is crucial in tracking the growth of a plant. Additionally, I've also been working on some of the motors. So PWM is a concept known as pulse width modulation, and it's used to drive the motors in our project. So our actual CNC gantry, in order for it to move, we have to send some kind of computer signal. Part of that is called PWM, and some of the work I've done involved setting up PWM for the vertical lifter. So that's a component of our machine that lifts up and down, and also for the shutter servo, which lets our machine dispense seeds.
My name is Dylan Collier. I'm a computer engineering senior. On this project, my role was the lead engineer on the project. So I directed all of the mechanical design. I led a couple other students who worked on the mechanical design. And then moving into this semester, working on the software architecture, I also led the main design behind the software architecture and a lot of the instruction on how drivers should be implemented and stuff like that.
I'm Nathaniel Bowles, and my major is computer engineering. Originally, I did some project management stuff before the Capstone started, because we worked with a lot of people beforehand to get it set up and the mechanical part. But whenever we got to the computer engineering part of it, I worked a lot on the software of the embedded system, the sensor data, and controlling a lot of the arm movements, and just a lot of embedded programming, mostly.
I am Jackson Hodge, and I am a Bachelor of Science in Computer Science. We actually have 3 different circuit boards for this project. I am in charge of the Raspberry Pi, completely. So I take in all of our sensor data, I store it, I make it look nice, I present it to the operator. I've dealt with some managing the other microcontroller because it's not as smart as a Raspberry Pi. So that was my stuff. All of the physical stuff was basically handled by Dylan. It was helpful as it gave me experience with working with low-level embedded systems and then turning that low-level data from those sensors into high-level overview for operators. My favorite part of this has been dealing with the finite state machine for our robot. So we have a big finite state machine for the gantry that controls, if we're in this stage and we get these inputs, where do we go next? Do we move the head to go pick up a plant, or do we mix some more solution, or do we need to turn on the lights or something? Dealing with that's been pretty fun. We discussed formal state machines in formal languages, but I've never actually had to build one for a program like we did for the robot, so that was cool.
The biggest thing for me is project planning in a group environment. So really making the considerations for how you bring a whole group of people up to speed on something and ensuring that your work, like the way that you work, the software environment, or just how you disseminate information is set up in a way that is best for collaboration.
Easily a lot of embedded knowledge. So going into this semester, I didn't have nearly enough embedded knowledge that I needed to as a computer engineer, but I learned things like how to work with lower level C libraries, how to write cleaner code. For example, a lot of my code originally was a little bit of a spaghetti, but after working with Dylan, I learned some really cool conventions, and I've been able to implement that through some of my next projects. I've also learned lots of embedded concepts through my embedded course and through the project itself, like PWM.
A lot of the problems you encounter are just a lot more manageable than you think they are. So just knowing that you can sort of accomplish and build things that you didn't think you could before you started the project, it was really great. All of us had our own sort of skills. One of us was better at more the computer science part of it, and then 3 of us were computer engineers, so we all kind of learned specific parts of what we need to do and specific things, and we just worked really well together as well.
I think what I learned the most is, better team dynamics, is when to push and when to pull for, expecting things from other people and trying to get everybody on the same page and trying to cater best to everybody else's strong suit.
Everyone on the team is amazing. Everyone was always really open to working together, always really friendly, willing to help each other. Awesome people.
I was very excited to do this project. I think this project, it better emulates a open-ended project in a workspace than, like a personal project where there is no pressure to complete it. I would encourage all engineering students to try to embark on a truly large project like this and really get in the weeds of only you and a small group of other people that can rely on each other to solve this set of issues in front of you and really work through those problem-solving skills.
Hydroponics and aeroponics is kind of relatively new in terms of technological use for it, so I think there could be a lot new innovation for hydroponics and automation and other things. So it could be in the future there's a lot of agrotech for smaller scale hydroponics, and especially for automation, because our project was doing hydroponics at a scale and automated that really we couldn't find on the market or anything like that. And so I hope somebody is able to do it efficiently and effectively for the future.